Okay, so, hey, I want to go over your 12 days of statistics very carefully. Make sure we tie up any loose ends. Okay, one of the things today that I want to really make sure I stress to you is the work that has to be shown versus what you can just go, put in your calculator to plop out the answer. Okay, so I want to make sure you understand the minimum amount of work that you have to show to be able to then get credit. Okay, so you looked at these while I was passing out or going around stamping, and this one, the first one, is actually pretty straightforward because the events had nothing to do with each other. They were independent. Then you just would show that you multiplied those two numbers together to get this. And this key is from last year, and so of course this year I'm wanting you to put these as percents. Alright, and then on the second day, this was another one where if you want at least one female, then you're going to do 1 minus the probability of none of the turtle doves being female. And if none of them are female, then that means they are both male. So that's both of them. This is the work you would show them both, 1 minus both of them being male. Okay, questions there? Okay, they're pretty straightforward here at the beginning. Plus, I'm going to put this key online, and I'll put that all the homework things. So if there's anything of this you didn't get to write down, or you were confused and you want to think about it a little more, then they'll be located online this afternoon. Okay. The third day was a straight up binomial PDF. So, because in particular, all that you needed was exactly 2. So just the 2. You have to do this part as your required work. Then you can go off to the side and blip that answer out. So what this is saying is the probability that you have exactly 2 French hens or whatever it is. This is your combinations out of 3. You're going to choose 2 French hens. This is notating 2 French hens, and if 2 of them are French hens, then 1 of them is not. Okay? And that formula, is coming from their formula chart right here. Okay? So this is not something I'm just coming up with. We've been doing this, and that's where that is coming from. So you need to be writing that down. Okay. Now, you do not, it is not required. I do it because for a teaching tool, I need to show you what you have to put in your calculator. But calculators speak. Writing out what you typed in your calculator like this is nothing as far as showing work. So this isn't required. I'm only putting this for the teaching aspect of it. And if I was a student, I'd probably put those on there too so that I'd know how I got my answer. Especially if it was wrong, I need to say, well, then what did I put in to get that? Okay. All right. Any questions on those first 3 days of statistics? Those are pretty straightforward. All right. When we let's look at the 4th, 5th, and the 6th. These start getting a little steeper. Actually, 4th day is straightforward geometric. Okay, so this is a good one. Where it just says, I want that first calling bird to be on the 3rd day. That defines an order. Not on the 1st, not on the 2nd, but on the 3rd. So that then looks like this. Okay, as far as work goes. The other way you could show this work, especially if, say, it said not until the 10th day, and you don't want to write out all those .37s, if it said something different, you could just write it with, of course, exponents, how many of those you want, and then the last one that happens. So that's the way you would show the work. And then in the calculator, you can certainly type all that out in your calculator, but here is what you can put in there to make it be simpler on you. It is PDF, because I'm only talking about just happening on the third. Not on the first and on the second, it's just on the third. That's 0.63, comma 3. Okay, how y'all doing on that? Okay, because you're not like saying anything, so I don't know if you're cuckoo, have no idea, or you're like, okay, we're pretty good. Yeah, cuckoo for Cocoa Puffs. Okay, now, so let's look at 5th day. This is where we start getting into a little more complex situation. So, this says, what's the probability of getting 3 or fewer golden rings in the 5? So, here's some things. Number 1, every single time you are picking 5. It's not saying how many until you get whatever. It's out of 5. That's what makes this problem a binomial problem. So this tells me it's a binomial problem. Okay? The fact that n equals 5. Because that means there's a set number that I'm going out of. Okay? That's what tells me it's binomial as opposed to geometric. Okay. Then, for me, this may, to you this may seem babyish, but for me, I need this because I just, my brain works slowly sometimes, especially by 6th period. So here, I want 0 through up to 3 because it says 3 or fewer. And the 4 and the 5 are what I do not want. I'll tell you another reason why this is helpful. Sometimes it's, you're unsure and it's unclear where the actual inclusion stops. Do you include the 4 or do you not include the 4? Do you include the 3 or do you not include the 3? So sometimes that's questionable, and that is very important. So I like to draw it out. That makes it much clearer in my mind. Okay, so I want up to and including 3. So, here's the work you show. Okay, so I'm circling in blue the work you show, which means this. I want to get the number of golden rings should be less than or equal to 3. So this means I now have a whole section. I have a sequence of events. Do you want to write, or do you want to compute the PDF for 0 and the PDF for 1 and the PDF for 2 and the PDF for 3? Do you want to compute all those PDFs? Not really. So then let's use the cumulative feature in our calculator, which all cumulative is doing is adding together the PDF of 0 plus PDF of 1 plus PDF of 2. So cumulative is just adding all those PDFs together. All right. So notice, you put the first one in the sequence. Here is the formula for the first one in the sequence. That's 5 choose 0 with 0 successes and 5 failures. Plus, dot, 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 plus, and the last one in the sequence. 5 choose 3, 3 successes and 2 failures. Okay, so that's the work that gets shown. Now, go ahead. Yes, ma'am. Absolutely. You identify the first in a sequence. If you have a series of events, just identify the first plus dot 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 plus the last. And then come over to your calculator and do whatever the heck you want to calculate it with. And for me, I just did the cumulative up to and including the third amount. So this is what I did in my calculator, but I don't have to write that down. What I boxed in here in blue is what's right. Okay, how's that? Clearing up some things? Kind of. Do you see now what you need to write then for that? Is that better? Okay. All right. So let's talk about this 6th day, or the 6th day, and we got geese laying golden eggs or something like that. I don't know. Maybe I'm just making up the golden part. But they are geese that lay eggs on or before the first one out of them. Okay, so let's talk through what kind of thought process I went on this. Okay, so Um, One thing that clued me in that this was geometric, the first thing that made me think, okay, this is a geometric one, is there's an unlimited number of events. So I am not doing something such as this and say, boom, check 5 every time. Or there is 5 that you are looking at. Okay. Oh, no. Knowing the order that they go in. Yeah. Geometric is knowing you have a specifically defined order that they need to occur in. And that's what we have here. So let me now explain to you what wording is cluing you into the order is defined. Okay, so here we go. So it says the probability of getting a laying goose, aka probability that the first goose that is a laying goose, okay, that lays golden eggs or whatever, is going to occur on or before the 4th trial. So that's actually a wrong thing right there. But so on or before the 4th trial. So here's what it is. This specific order of where they occur is important. So you're saying, I want that goose to occur on the 1st place, and I don't care what happens next. Or I want it to occur in the 2nd spot, and I don't care what else happens. Or I want it to occur in the 3rd spot, and I don't care what else happens. Or I want it to occur in the 4th spot. So I'm defining the location that the 0.83 happens. That's knowing the order. That's geometric. Alright. So therefore, the easiest way to calculate this in your calculator, and then I'll show you the word. The easiest way to calculate this in your calculator would be geometric CDF, because it's all of those ones. I want 0.83 to occur up to and including the 4th spot. So this is what I would do in my calculator, but let me show you probably the least amount of work that you need to do would be this. I want the 0.83 to occur on the 1st time, plus dot, plus the last one in my sequence looks like this. The first 3 are not, and the 4th one is. That's it. So this is how your sequence is showing the first one happens on all the way up to the 4th one it's happening on. Okay. Because when you have the first one, it's just 0.83. So the 83% occurred on the first goose that first goose was part of the 83% that lay eggs. Yes, you could do times 0.17 to the 0 power. Absolutely. Yes. Okay. Alright. Okay. Good. Questions on that? So then next, so turn over your page and let's look at the 7th and the 8th and the 9th day. Okay, 7 was pretty straightforward. It was talking about probability of the swans drowning and it being exactly 4. What makes this a binomial problem? The fact that they're checking what? It doesn't matter where the 4 are in your, amongst your what? 7, thank you. Because you are checking 7 swans, you're going, boom, here's my 7 swans, let me check them. Boom, there's another 7 swans, let me check them. Okay? So that's what's making this a binomial, because n is 7. I'm not going, go until you get a drowning. Alright. or what's the chance that your first drowning swan occurs on the fourth one? Okay, so it's just straight up binomial formula. So this is the work that has to be shown. I just am writing the formula. And then here's what I type into my calculator to plop out my 4.47% chance that when I check 7 at exactly 4 of them will be drowning. Okay, good. Now, the 8th and the 9th day are about expected values. Okay, and we talked about that yesterday with our little formulas here. So let's kind of review this section of the formula chart. It's binomial if they tell you how many it's out of, and the question would be something like, out of 150 people, how many of them do you expect to have, type B blood or whatever it is? So they will tell you how many to check, and then you're finding out how many you expect to have whatever the thing is. That's this formula here. So that is what we have going on here. Out of a group of 8 maids of milking, how many do you expect to be sour? Okay? So look here. Does it make sense that that number can be 3.04? Yeah, it doesn't make sense. But the answer is 3.04. Do not round to 3. Why is it acceptable as an expected amount to be 3.04? It's expected because it's an average. It doesn't have to be what exactly happens. Just on average, what's happening. In fact, even whenever you look at the formula chart, well, how is this notated? What's that symbol mean? Average. It's the mu for average. Okay. All right. And then the next one, on the 9th day, how many do you have to go until one of the ladies accepts? That's geometric. How many are you going to go? You don't know you don't know that you're checking 8. How many are you going to go until? So that's geometric, and that is the one that is not on the formula chart. You have to know that the expected for geometric is how many you go until you get 1 is 1 out of the probability. Okay. So then that's 1 out of 0.18, and so on average about 5.56 will have to go to. Okay. All right. 10, 11, and 12. I'm going to not do 10 just yet. That's table 10. Let's talk about 11 and 12. Actually, let's go backwards. 12 is the easiest because it's just a straight up formula. 12 is find the standard deviation, and there is a set number, n equals 12 drummers drumming. So therefore it's binomial. And the standard deviation for the binomial is using this formula here. Okay. So that's how you did that number 12. Just plugged into the formula, boom, you're done. Okay, I actually should label these things. This is drummers. I mean, this is not a percent. This is an amount of drummers. And up here, this is an amount of ladies. And this is amount of milkmaids. Okay, so the other things are percentages. Those are actual items. Okay, 11th day. Out of the frozen pipes. Okay, so out of 11. Boom. It's out of 11. So you know this is what kind of problem? Binomial, because n is 11. Okay, so that's my first thing. So again, because I'm kind of slow on the uptake, I draw out my little numbers here. 0, 7, and then you got 8, 9, 10, and 11. So find the probability that 8 or more. So this is what I want. So you are welcome to put this in your calculator as PDF of 8. plus PDF of 9 plus PDF of 10 plus PDF of 11. It's a little tedious and long, so we have other better options. But let's talk the work you need to show. I want the frozen pipes to be greater than or equal to 8. So then I fill in the formula. Why do I have two things? Why do I show the dot, dot, dot? Why does this one have the dot, dot, dot? Because I want several things. I want 8 of them up to wanting 11 of them. So it's a series, because there's a sequence of events that are acceptable. So you do your formula for 8 being acceptable up to 11 being acceptable. So that's what you want. So that's the work you show. Now the thing is, that might not actually be what you type in your calculator. Could be, you could go PDF of 8 plus PDF of 9 plus PDF of 10 plus PDF of 11. But a better way might be a simpler way, less calculator steps. How about 1 minus this whole section down here that I do not want? And this whole section is cumulative up to and including 7. So I want to knock off up to and including 7. If you put an 8 here, you're knocking off 8 also. You don't want to knock off 8. You just want to, where's that? Sorry. Okay, that would be, here we go. You want to knock off up to and including 7. So 1 minus cumulative, all of them up to and including 7. And that's 37.1%. Okay, that's one. I kind of want to actually do this one with some more space. So this problem says this. What's the probability that the first lame lords a-leaping that you find, this right here is saying you don't know how many you're going to look at. Because you're going to go until you get the first lame lord a-leaping. So right now, this is already telling me a kind of which distribution it is. But anyway, probability that the first lame lord a-leaping is after the 6th one that you check. Okay. So do I have a set number that I'm checking? I do not. Therefore, this is not binomial. Therefore, this is geometric. And so, out of it happening on the first, happening on the second, happening on the third, and so on, the 6th, the 7th, all the way up to it happening in the infinitieth one, okay, because it doesn't give us a stopping point. What do we want? What section of this do we want? After the 6th, I want 7 up to infinity. I want to have the first one that's allowed to occur is on the 7th one I check, or on the 8th one I check, or on the 9th one I check, or so on and so forth. Okay. So, by the way, all this up here is the geometric PDF of, 7 plus the geometric PDF of 8 plus the geometric PDF of 9 plus the geometric PDF. So I'm just saying, if you did all of them individually, it's going to be a nightmare going out to infinity. You pretty much can't be. So I can't address what's all the way to the right. What do I have to do then? Then I have to take off all of this part to the left. So that's 1. So here's what I'm going to actually show you what you do in your calculator first, and then I'll show you the way I think the simplest way to write it is. So to compute this, it's 1 minus all of the cumulative distribution frequency. That's what that stands for, by the way. What's the probability? 0.24. And all the way up to and including 6 is what I want to knock off. Okay, so there's that. That's what you type in your calculator to get your answer. So I don't think I've ever really seen one of these as a free response that this is this in depth, but here's the way I would show my work. Since this is going on forever to infinity, I think it's easier just to go 1 minus, and then I'm going to demonstrate this. The lame Lord of Leaping happening on the 1st, all the way up to it happening on the 6th. If it's happening on the 6th, then what's in front of it? 5 of them that are not lame. So this is kind of like above and beyond. If you get this, fine. I wouldn't worry about it if you don't. I think that's probably the most succinct way that you could do that. Okay. So there's that. What I want you to do right now is do your warm-up. And while you're doing your warm-up, I'm going to pass out to you all of your quizzes. Okay? And so what you're going to be able to do with your